just to remind us firstly that what we're looking at here is injecting liquid CO2 into a porous rock about a kilometre deeper, and that will be overlain by an impermeable lid, a layer of rock which does not allow the fluid to come back upwards towards the surface. That's what you're searching for. And the other key attribute for the storage is we're looking at the storage offshore, beneath the North Sea probably, not onshore like we talked about fracking earlier on. So at the moment there's very little public concern about that, and that's the way the government and the industry and ourselves want to keep it. Now, the key attribute about storage is that the UK, partly because of the geology which gives us the oil and gas, the UK has got a huge amount of potential carbon dioxide storage, about 70 billion tonnes, that's 70 with 9 zeros after it. And for the UK alone, that would be about 700 years worth of storage. So that's low storage which is yet unproven. It's predicted but not proven. And the key attribute here is that when that is proving, that validation and development of the storage needs to occur before the projects get their final investment decision to build the power plant, because no commercial company is going to go ahead and build a power plant with carbon capture maybe costing £1 billion if they don't know for absolute certainty that they can inject that CO2 from the power plant for the next 30 years into the future during the operation of that power plant. So there's a difference in lead time of storage. Storage needs to be developed first. And if you back calculate from the types of numbers which Jim Watson was talking about, say we had 15 gigawatts of electricity powered by CCS in the mid-2020s, then we need to have about 900 million tonnes worth of CO2 storage established to a commercial quality by the mid-2020s. At the moment we've got 0 tonnes of CO2 storage established to commercial quality. And if you discuss this type of exploration circumstance with oil and gas company developers who are well accustomed to discovering the underground, then they would say that would typically take 5 or perhaps even 10 years to explore a new area to the quality required to establish that storage. So the message here is that there's a very important issue which could be of huge benefit to the UK to exploit its own storage, and also potentially to sell that storage space to the European Union countries who have very little onshore storage available for their own domestic storage. We have a huge business opportunity there, but we're not looking at that in a practical way and in a practical testing way. And
can you just give us an idea of what 900 million tonnes of storage looks like in terms of area?
Oh, geez. 900 million tonnes of storage would be about, let's see, about
Blackpool?
No, bigger than that. About 10 gas fields worth, let's say. And a gas field might be something like 15 kilometres long in footprint. So they're quite large areas you need to evaluate on the ground. Okay. But again, this is routinely done by oil and gas companies. We have the technology available to do that, but it needs to be applied in a directed way. And at the moment, there's no incentive for companies to do that type of investigation because they can't see the visibility of the business. And it's front-end money with no guarantee of any revenue at the moment.
For your 10 gas fields, that equates to how many hundreds of million tonnes or billion tonnes?
I'm looking for, if we're to roll out carbon dioxide capture and storage with 15 gigawatts of power, like Jim suggested, we need to have 900 million tonnes of storage proven by the time those power plants go to the electricity company board of directors for approval. That's one of the big ticks for the whole chain to work all the way through. No point in capturing carbon dioxide unless you can actually inject it in the ground. Now, one big blockage is the lack of practical investigation. The other blockages are, which we make points of in this report here, we're talking about firstly the site selection needs to be high quality. That's the key step to reduce the risk and any future lack of performance. And the past history of UK government investigating nuclear disposal sites is a dismal failure because the government has not paid enough attention in a systematic way to how to involve the public in that debate, and also how to establish a good technical case for nuclear disposal sites. So we've been investigating nuclear disposal sites since the middle 1970s. There's presently a consultation going on in West Cumbria, which is probably one of the worst sites in the UK for radioactive waste disposal. So it's a serial and continuing failure by government to Secondly is the liability types of issues, and I'll here draw a distinction between the liability for operation during the disposal operations. That's relatively straightforward to understand. It's rather like extracting oil and gas from an oil field, but in reverse. A company is very happy to manage that type of liability. But with CO2, what we need to do is streamline that liability, so we need to have that a capped and limited liability which the operator takes on board, and a good quality operator will be happy to take that on, I think, with some set of arrangements, for example, initial liability from the operator, then some compulsory insurance to take the next stage of any accidental CO2 leakage, and then ultimately it's still going to be the government takes the liability on that. And then secondly, and perhaps most importantly, is the liability after the operation of CO2 ceases. And there's a well-established problem between the European Union CO2 directive and the practicability of actually doing this in commercial terms, because we in the UK are subject to the European Union directive, which says that an operator needs to have liability for that carbon dioxide in perpetuity, unless the member state, i.e. the UK, transfers the liability to the member state at some stage. So there's a huge debate in the industry about when that liability should transfer, and that's a seriously and potentially terminal contractual blockage at the moment. And this report proposes that, like radioactive waste, we think of some system where the state has to take long-term liability for the CO2 stored and has to underwrite that, and the debate then comes around what timescale that occurs in. The government at the present moment is not committing itself to anything, but it's very clear that for a practical industry that needs to be a timescale between 5 and 20 years after the immediate operations have ceased to enable that commercial proposition to flow for the benefit of the UK. And there's an opportunity for the UK to get involved in that, because the European Union directive will be revised in 2015, and if we need to look ahead, we need to plan now to get our act together for that 2015, because we are very large stakeholders.